Thank you very much, Louise, and hello everyone. Welcome to OTF Connect. Thank you for giving of your own special time to be with us tonight. I'm delighted to see so many here in the room, so wonderful. And I think we have some new participants joining us tonight, so it's always wonderful to have new teachers here, and welcome the ones who have joined us in the past. Tonight's session is part 2 of a series in math to help support the math process. It's my pleasure to welcome Maria Van der Lees, who will be facilitating tonight's webinar on using critical thinking to foster number sense in elementary math. Maria is a facilitator with the Critical Thinking Consortium and obviously presented part 1 of this series. So she brings many wonderful and creative ideas and much experience to share with us tonight. So welcome, Maria, and welcome everyone.
You know what, Maria? I can see that you've got a chat bubble, and I just want to let you know that your mic's not on if you're speaking. If your mic button won't turn on, if you go up to View and Restore Default Layout, that often resolves a frozen interface.
That's usually my problem.
Okay, can everyone hear me now?
Yes, and know what,
okay.
Before you get started, I just noticed that Dawn said she can't see the chat. Dawn, make sure that where your chat title bar is, click that little triangle on the left and make sure that your chat is maximized. Sorry about that. Go ahead, Maria.
Okay, great. Well, welcome everyone. It's great to be with you. Thank you, Syria, for the introduction. I just would love to know, just with a little check, how many of you participated in the first session that we ran about a month ago? Okay, so a few of you, and just to let you know, I will be building on some of the ideas from the first session, but also reviewing what we did. So you can absolutely participate and come into these sessions at any point. But there's a few things that refer to what we had done. And if you're unclear, just raise your hand and I'm happy to go over and explain everything to you. One of the things I wanted to know for those who were at the last session, but also if you weren't, just in general, if you want to share what some successes you've had in your math class so far this year and what some of your challenges are. And perhaps we can have people just writing in the chat box about this. Or if, Louise, if you think it's okay, we can have people writing right on the interface with the text tool, which is the 4th one down.
Whatever works for you guys. So if you'd like to contribute, just right on the slide in the open spaces there, just select your text tool or type away in the chat.
Okay, so Dawn did a 3-part math, which was a success. That's great. Okay, someone's not teaching math, but it's part of a school improvement plan. Wait time. Yeah. Using math games. And if there's any challenges that you've been experiencing so far this year, you know, please share them as well. So ESL. Getting kids to explain their thinking more clearly. Well, good. I hope tonight's session helps you with that. And I noticed a number of people also speaking about math talk, and we're going to speak to that, about math talk and number talks and ways we can bump up the critical thinking in those activities. Right, so resilience being an issue, starting strong but quitting when confronted with a challenge. The math curriculum to parents, absolutely, that can be a challenge. Okay, great. Well, I certainly hope that that tonight's session will help fortify the things that you are experiencing success in, and give you some real affirmation about your approaches in math, and also provide some insights into some of the challenges that you might be experiencing. So for tonight, the goals are really to frame our own understanding of number sense as educators. So how do we understand number sense? Explore the value of infusing math learning with critical thinking as a way to foster that deeper concept attainment in number sense, and continue to consider the ways that the Critical Thinking Consortium's framework helps us to tweak our tasks and fortify our tasks in ways that really do support math learning. So specifically when it comes to teaching number sense, I'd like people to write on the slide. What is it that you feel excited about, and what are the things that you feel concerned about as a teacher? So games and fun, which is great. The structure of math, right? Something in the day-to-day. Concern about the number of kids in intermediate that cannot do the basics. Not knowing all the strategies. And there's a lot of different strategies too, so we're all always learning about the different approaches. Concerned about teachers not feeling qualified to teach math. Excited about open questions. Yeah, open questions are wonderful, and that's something we will be looking at tonight as well. Using manipulatives, smartboards, interactive websites. Concerned about finding ways to engage students and parents outside of school hours. Having students choose a strategy that isn't the most effective for them. Right? Concern about balancing open questions with rote tasks. Well, thank you to everyone. I think some of you are still writing, so just give you another moment here. Oh, someone mentioned Prodigy, a great way to engage kids outside of class. I'd love for the person who wrote that, maybe if you could take a moment and just share with us a little bit about Prodigy and using it. You can just do that by turning your mic on.
I can see Amanda and Kristen are typing. I'll jump in. My son's school uses Prodigy, and my son loves it. He definitely will sit down at the computer, and I'll turn around, and he can be playing Minecraft, or he's going to be playing Prodigy. And so it definitely does get them thinking about their math outside of class in a fun way.
And can you share with us a little bit about Prodigy, because some people may not be familiar with it?
Well, my understanding is that it's software. It's got a certain degree of tuition to it and is able to kind of gradually build up in difficulty of the questions as he's playing, but it's kind of more in a game format, and then there's challenges that of course are related to solving math problems, but the kids are excited about those challenges as opposed to, as I saw that people had said, you know, that kids seem to kind of give up when they hit that challenge, and I think in the game format they seem to look forward to it instead.
Okay, great. Thank you. Thanks to everyone for and what you're concerned about. Okay, I'd like you to look at these two different approaches to number sense, and just think about, to start off, just take a moment to think about which do you feel is the most effective in fostering number sense. Okay, so a number of you in the chat box are writing 1. And as someone said, Kelly, the first one makes more sense, but the second is how most of us were taught, and that's the challenge. And thank you so much for saying that, Kelly, because I think it is one of the challenges for many of us as educators, and it's about our own unlearning of the ways in which we were taught math and the ways in which we conceptualized math as a result, because I would argue that many of us did not gain that deeper concept attainment in many ways, and at times were turned off from the subject. And so now to be in the position of not wanting to necessarily reproduce that, and yet we're also in a time where this tension is so alive, and many of you mentioned how you know, communicating with parents is one of the issues. You know, there's that sense of always these swings and shifts in education around, you know, the 3 R's and the practice and the rote. And, you know, again, there's room for practice, and there's room for math games and things that build some of the fluency and flexibility. But when that's our only approach, then we do lose that deeper concept attainment. So, you know, when is it appropriate to bring in the fun drills and, you know, making speed something that has a place in our math class, and yet also being critical and asking some questions about, is that really what the focus is, and what are we really striving to achieve as educators? And someone there, Kristen, has said, my students have bought in, but it's the parents. And, you know, there are a number of teachers who are speaking about how in their classrooms they do a lot of the problem-based learning and rich tasks and open tasks. But part of what they do for homework is they will send some practice home. And so, you know, most of the homework that's going home is not the rich tasks that are worked on in class and really get students thinking, but some of the things that might build some of the consolidation, that might build some of the flexibility and fluency. So I think that balance is possible. But as many people are, and many of the teachers here I see are commenting in the chat box, number 1 is probably what resonates in terms of, you know, what we're aspiring to do. So even in the task that I just gave you when I asked you to say which is the most effective, you know, for many of you it was pretty instantaneous. But even to think about what is most effective, that in and of itself is a critical thinking task. When you're having to judge or make choices among options in light of criteria. So, you know, that was even just a little warm-up of needing to assess, well, what is effective? I think that with the example I gave you, it's something that as teachers we're thinking a lot about. So that is a critical challenge that we have, is what is the most effective way that we can teach our students number sense in light of the different approaches and strategies. But just to review, this is the definition that we work with within the consortium. And there's two useful questions to guide our inquiry tonight, but I also think, beyond this, this workshop. How can the intentional use of a critical thinking framework assist us in fostering strong number sense in our students? And how can we effectively design reasoning and thinking tasks to foster the deeper conceptual attainment required in order to develop mathematical fluency and flexibility? So again, just to review, critical thinking is thinking through a problematic situation about what to believe or how to act, where the thinker makes a reasoned judgment that reflects the competent use of the intellectual tools for quality thinking. And we're going to review what that is. What are those intellectual tools, and how is it that we can teach our students those tools so that they become part of what the student can use independently, not just in our classroom, but they become internalized and part of what they do whenever they're confronted with, a challenging situation or something they need to think about. I loved one teacher's description of numeracy and said that, often numeracy has gotten put into this box that, it's about numbers and it's its own little world, but she saw it as something which transcends mathematics. And numeracy is really about, at its core, it's about logic. And it is about being able to think. And when we look at the ways that we're being asked to focus on critical inquiry, it really does open up new and meaningful ways to engage students in the productive thinking about math, and helps to build those deep foundations in number sense. So again, thinking about how are we approaching critical inquiry in our classrooms. So just to review for those who weren't part of the first session, the framework that we're working with within critical thinking is there's 4 approaches to create a thinking classroom. One is to nurture thoughtful communities, to frame critical challenges, to teach the intellectual tools, and the intellectual tools are right there along the bottom, and to assess thinking and performance. So we look at intellectual tools. Whenever we have a challenging situation to think through, we need background knowledge, we need the criteria for judgment. So even in the question I gave you, when we're looking at effective, well, what does effective mean? Critical thinking vocabulary. Do we understand when we're asked, for example, what a reasonable solution is, or to estimate? That's part of the critical thinking vocabulary we need to make sure we understand before we can engage in a challenge. The thinking strategies, so in mathematics, some of the ways we might think through a problem would be a number line, or manipulatives can be part of our thinking strategy. I mean, there's just so many ways that we use thinking strategies. In other situations, we might use a pro-con chart. We could web what we're thinking about. So again, how do we intentionally teach some of the thinking strategies to work through a problematic situation? And also the habits of mind. So, some people are talking about resilience in their students and perseverance in the face of a challenge. These are some of the habits of mind we also have to explicitly teach. I just want to make sure I'm getting the comments as well. Dawn's mentioning she's been using a math scrapbook for several years, and that's her homework. That's amazing, Dawn. Love for you to have a chance to perhaps share that with us. The kids love it, parents love it, the kids connect to what's being learned in the classroom. Gianni says it's about relationships. It's so much about relationships, and it's not just the relationships with kids, but math has often been presented as a whole series of facts, but it's mostly about the relationships between those facts. Beth, please go ahead.
Could you share a little bit more about a math scrapbook? I haven't heard the term before.
So Dawn, did you want to share a little bit about that?
Now I know Dawn doesn't have a mic, so she's going to be typing furiously for a moment, but I can see she's doing that.
Okay, so so I'm going to move on, and then we can take a look at what Dawn has to say. So one of the things I want to talk about tonight is really about how we nurture thoughtful communities. And a number of you have mentioned how you're doing this in your classrooms already with Math Talk. And we're going to look at some of the ways that critical thinking helps to support the building of these thinking communities. We also are going to look at framing critical challenges and a little bit on teaching the intellectual tools. We did focus on that in our last session. Again, in all of the sessions, we'll look at different aspects of the model and go into some areas more deeply. So how would you describe Melanie's number sense? And you could write right on the slide, or you could write in the chat box. So Summer saying she understands that 110 is equal to 10. So I'm just going to go back up here for a second. 110 is equal to 10 ones, and she's regrouped them. Avoid use of bigger and change that thinking to value. She's following a process that she's learned, but her number sense isn't great. So a number of you are saying that what she's describing here represents more of a formula as opposed to that deeper concept attainment. She knows how to follow procedures. Okay, so a number of you are saying that, you know, that really her deeper conceptual attainment isn't really being reflected in what she's communicating. That perhaps she has learned through more of a formula. You know, that's what you do when the number on top is bigger than the one on the bottom. So let's look at some ways that we can use number talks or math talks to help to build some of that deeper concept attainment. So just take a moment to look at this slide around what children with well-developed number sense understand. They can make meaningful use of number relationships. They can decompose and compose numbers. They can, you know, break them apart and put them together in different ways. They have a familiarity with landmark numbers, and they're able to estimate. And it's quite interesting. I think I mentioned this in our first session, but when they've done some very profound research on students and their number sense. And what they found is that when students don't have that deeper conceptual attainment, it is so much more difficult because the way in which they understand math and the way that it's represented even in their own thinking is a series of steps on a ladder, and they're just sort of memorizing and scaffolding rule upon rule, and they don't have that inherent flexibility with the numbers. And it's that process of being able to break numbers apart, put them back together in different ways, that is the heart of the fluency and is what allows people to work with that speed. So how do we, again, make that more of our learning target? Not that sense of rules to memorize that students are constantly searching for what's the rule that applies in this situation, but that inherent confidence that they feel when they see a number. And thanks everyone for jumping in terms of the chat around landmark numbers there. So one of the big ideas when it comes to number sense is that number sense really does develop with meaningful experience. So many of you have spoken about using math talk, and that is a very important strategy because it is a place where students can engage with the math in a meaningful way. So when we, again, look at our framework of critical thinking and nurturing thoughtful communities, math talk and number talks are important. Someone's asking, is math talk and purposeful talk the same thing? Well, yes. And also number talks, which are a little bit different, is something that there's a great book, and I do make a reference to it at the end, so it's there for you. Number talks is specifically around building number sense, whereas math talk is something we can engage with, across many of the different disciplines or strands of mathematics. Number talk specifically is when we're engaging in intentional discussions around building number sense. So it's about looking at questions, usually around the traditional algorithms or operations of addition, subtraction, multiplication, and division, as well as the increasingly complex forms of our number sense around fractions and integers and decimals, and actually having scenarios where we're able to talk about the different ways that we represent our thinking around that operation. So I'm going to lead us through that right now. So this is specifically a number talk. So using mental math, how would you find the sum? So I want you to, again, you can write right on the slide itself or in the chat room about how you found the sum. And when you've done that, also to think about whether there's some other strategies you could use to solve this. Okay, so I have to say I'm finding this really exciting. So to me, this is really wonderful to actually see all of the different ways that people conceptualize this problem. And that's what's so exciting about number talks, is creating that community in our classrooms where the intention with a number talk as well is not to intervene right away and correct a student if their strategy hasn't led them to the right answer, but to allow that to surface organically, because it absolutely will. But more to focus on whether we're accurately representing what the student is telling us. You can imagine if we did this orally and a student said, well, first, I took 30 and 30, and then, I subtracted, or, I added 4 and subtracted 2. And your role, as an example, could be to visually represent that on the board. You could take that role. Another thing you could do is have students represent them and put them up, and of course have discussions around that. But it really is focused on representing what the student is thinking. And this is incredibly exciting. And it's exciting for students because this is the moment where we move out of that traditional sense that there is one right way to do this. There is a right answer, right? There is, 34 and 28 has a definite answer of 62. But when we look at all of these different representations, it is where we see the creativity that is a part of mathematics that's often so denied and so excluded from the classroom, right? But it's so exciting to see all of these different solutions. I don't know if anyone else is excited by it. I'd love to know if you also think it's really cool to see all of these different ways of thinking up here. So again, some possible strategies: traditional algorithm. Some of you talked about that. I just lined them up in my head. Counting in chunks, use place value, make friendly numbers. Again, were there any other ways that we missed? Did anyone's strategy not really fit into one of these four? Just seeing some people writing, so. Okay, and someone mentioned first thing the students do is ask what is the sum, and absolutely, and it's, you know, that's an opportunity to get a word wall going and you know, build their math vocabulary in these ways. Yeah. Okay. Great. So again, when we're talking about, and here's where we can fortify number talks with critical thinking, is to start having those conversations in class about what is an effective mental math strategy. And so we can start to bring that language in and having the students thinking about their own approaches and whether or not their approaches meet the criteria, right? So some examples is obviously an effective mental math strategy would lead us to the right answer. Efficient, it doesn't take too long. And again, I do want to give a little caveat with this notion of efficiency, because I do think that we can, you know, get so focused on speed, and some of the greatest mathematicians are, and they'll say like they're very slow thinkers. But you know, in terms of an effective mental math strategy, when we use mental math, there is that element of efficiency that we want to be a part of it. Well understood, you know, that you really know what you're doing. Suits the numbers could be another, right? And you can think about some other ways you can play with this, but again, getting students to think about their approaches in light of criteria and making those assessments and starting to move their own thinking along. Also, when they hear other people's approaches, one of the suggestions, you know, when you have students give you these different ways of solving a problem, as a teacher, you know, in building that community, you might say, okay, I'd like you to try Priya's method. I want you to look at, take this problem and use Priya's method to solve it. Or, and this time, okay, you've done that, now I'd like you to use Aaron's method. And in that way, you're helping to build that flexibility for them, that they start to see these other ways and conceptualizations of working with the numbers. Okay. So again, thinking about the criteria of accurate, efficient, well understood, which mental math strategy, so thinking of the ones we looked at, there was a number line, doing it in your head, working with friendly numbers, explain which mental math strategy is the most effective way for you to find the sum. I want you to think about that, and again, you can write right on the slide or in the chat box. I find friendly numbers the best, and I can use it when shopping. Yes, definitely friendly numbers come in handy, right? When we're trying to tally up what's in our grocery basket and all those 99s, and we have to use the friendly numbers to help us. That's interesting. Triple 44 and add 2. right? Friendly numbers. So a number of you are feeling that friendly numbers might be the best mental math strategy in this particular question, right? And again, so think about these ways you can play with students, play with the numbers with students, you know, and look at how some questions, perhaps just adding it in your head is, you know, is the easiest way. In other cases, the friendly numbers. In other cases, perhaps the number line. And this helps to build that fluency and flexibility in a way that really brings the deeper conceptual attainment to students, which is why I love these number talks so much. But also enhanced with the critical thinking, right? Because you can see that this task has now been fortified in a way that allows that deeper thinking and concept attainment to happen. They're making decisions about the math. They're making decisions about their strategies. They're assessing their own strategies, right? And again, you know, using product. This is a classic. Joe Bowler uses this question, and actually she's got the founder of Wolfram Alpha, which is a great website, who's using this all the time, this 18 times 5. You can have such great number talks around this. So let's just take a moment actually and write down your strategy for what you do to find 18 times 5. Some of them they've used the box strategy. I'm actually not familiar, or you know, with that. Could you explain that a little bit more? The box strategy. Okay, so you'd multiply the 10 times 5 and then add the sums, and then the 8 times 5 as well. And also, again, you can add to this and have students visually represent their strategies, which is exciting. And the more opportunities we give students to visualize their thinking, but also to present what we're giving them in visual ways, the more that really does help the concept attainment. And just to go back for a second to looking at children with well-developed number sense and thinking about what they're able to do, right? They can make meaningful use of number relationships, decomposing, composing numbers, use landmark numbers, and estimate. And thinking about the strategies that we've been using, we can see how these number talks, and especially infused with some of the critical thinking tweaks, really allow for that to happen, right? And again, in a deeper way than if we solely used drills in our class or wrote speed of, you know, multiplication, addition, subtraction, right? This is going to bring that confidence for students, and how much learning as well in seeing other people's strategies. Great. Thanks, Louise, for keeping those website links going too. So number talks or math talks can help students make their thinking visible and increases the opportunity to present mathematics visually, highlights the creativity often hiding behind the idea of one right answer by exploring the multiple ways of conceptualizing and arriving at answers. And also, and this is another important point, number talks and math talks foster an inclusive community of thinkers. And it contributes to what Joe Boulder refers to as relational equity. This idea of moving away from those who get it and those who don't, that I think seems to plague math class more than most subjects, and also has contributed to the deep anxiety that students and adults feel about math. And instead, we're creating a shared community of different ideas and ways of seeing and building through that sharing of knowledge, and each of us becoming better at mathematics through that shared learning. The second big idea I'd like us to explore tonight is that critical inquiry helps us provide the meaningful experiences that can in turn foster increased number sense. It opens up new ways to engage students in thinking about mathematics. So in our first session, we talked about different critical challenges. So you notice on the 4 fronts, one of them was building an inclusive classroom, and one of the other fronts of critical thinking is to provide critical challenges. And we've identified really 6 main forms that critical challenges can take. They're critique the piece, judge the better or best, rework the piece, decode the puzzle, and design to specifications. Okay, and then I've given some prompts on the other side, so you can just give an example, but there's so many ways across subject areas that you can use all of these different critical challenges, right? So when you're critiquing a piece, is decide if a solution strategy is effective, right? So you're assessing in terms of its effectiveness. You're critiquing it for effectiveness. Choosing between 2 strategies, which is more effective, that's a judge the better or best. Adapt a strategy to make it more effective. You're reworking a strategy that's already been tried. How does this solution strategy work? You're decoding the puzzle. Create an effective solution strategy. You're designing to specifications. So I've got a challenge here. There's actually 2 challenges, critical challenges, and I'd like you to see if you can identify which of those 6 critical challenges, which 2 of the 6 does this critical challenge set up? Okay, so we've got Al the alien visiting from outer space feeling discouraged because he cannot understand fractions, and he only got half his answers correct on his last test. So first of all, we need to look at Al's correct and incorrect answers to figure out his most significant misunderstanding. So that's our first challenge. And our second is to write a letter that provides useful advice to Al, to help Al overcome his difficulties with fraction and gain confidence. Okay, so I'll go back to the challenges. So one is we're having to identify the most significant misunderstanding. And the second is we're going to design a helpful letter. We're going to write a helpful letter to Al. So which of the 2 do you think critical challenges are there? You can write in the chat box.
Or might I suggest that you grab the clip art tool and drop a symbol over top of one of the 6, or I guess it's 5 types that are there.
Great idea, Louise. And again, don't let the questions on the left, because those are just some examples, but think about what each of the challenges is asking us to do. So one is to determine his most significant error, and the second is to write a letter that provides useful advice to him. So which of these six? Of critique the piece, judge the better best, rework the piece, decode the puzzle, and design to specifications. Okay, so some of you say critique the piece. So deciding, in that case, whether something's effective. Decode, a number of you said as well. In that case, perhaps trying to figure out his most significant misunderstanding could be a decode. The puzzle is, what is it that he's misunderstood, and we need to figure that out. Writing a useful letter, be designing to specifications. Reworking, so in a way we're trying to make something more effective. So again, these can be a little, the lines between them can sometimes definitely blur, and it's not always easy. Okay. So thanks to everyone for participating. And maybe as we go on, we'll have another opportunity, and you might think about or rethink some of what you thought in terms of the critical challenge. So when we're asking students to do this, we first of all have to figure out, how do we help them to identify a significant misunderstanding? We need to unpack the criteria of a significant misunderstanding. So it could be that it relates to a key idea in math, and it could be something that affects their further learning, right? That could be the criteria we come up with. It's significant if you don't understand something, if you're misunderstanding something and that continues, it's going to affect how you understand anything you learn from this point forward in this area. And the criteria for useful advice could be identifying the problem or misunderstanding, suggesting specific ways to overcome the problem, and giving helpful, encouraging tips for the future, right? And again, it's really great to co-construct when we can. It's not always possible. Sometimes we provide the criteria for students, but when we can co-construct together, because again, that brings a deeper conceptual understanding. Okay, so I'm going to ask you now to figure out, what is the most significant misunderstanding that Al has with fractions? And when you have that, again, you can choose to write it right on the slide or in the chat box. Okay, so a number of you have identified that Al's significant misconception is that when the denominator is bigger, he believes that automatically makes the fraction larger. So that's his most significant misconception. Are there any others that people have identified, or is that what most of you feel is the most significant? right? So he's not treating the fraction as a number in and of itself. He's judging by the digits. Okay, so not understanding the difference between whole numbers and part values. So again, thinking about this as a strategy, having a discussion in class about this when there is an error, perhaps in a few lessons, and you do an exit card, and you can use that to identify the misconceptions in class. And some teachers are choosing to do this, is create a scenario that reproduces some of those common misconceptions and ask students to figure out what the most significant misconception is. And again, it can generate that rich discussion, help the students who perhaps have that misconception understand it in a safe way, because it's being discussed not specifically around something that they've done, whether on a quiz or a situation that has more anxiety or high stakes, but through those formative assessments, being able to surface their thinking and start to address it in class like this. So this is, again, one suggestion of things you can do. And again, depending on your grade range, I've also done this, in a grade 8 algebra class, and given them different solutions to a complex problem and had them rate and rank those solutions, and also identify any common misconceptions that might be there. So again, just returning to the criteria, and this is something you can do with your students, is have the criteria up in the classroom somewhere so that it's always part of your discussions when they're giving their answers. So think about your answer. Does it relate to a key idea? Does it affect further learning? And when we think about the denominator, that is a key idea, that the sense that the denominator being bigger means the fraction's bigger. That's a very significant misconception and certainly would affect further learning. So you could open up discussions about this. I just want to make sure I'm getting your comments here. Use a mini version. Louise talks about a backwards design to have kids look at incorrect solutions and figure out what step needs to be corrected. And Vicki mentioned that last year teaching with fraction circles creates misunderstandings when comparing the value of fractions. So again, that's interesting. Looking at that, and how do we surface that thinking and know that our students are, make sure that our students are developing accurate understandings. And I apologize for some of the faintness of the writing here, but I'd like you now to think about, because the second part was to write helpful advice. So let me just go back for 1 second. Criteria for useful advice identifies the problem or misunderstanding, suggests specific ways to overcome the problem, and gives helpful, encouraging tips for the future. So with that in mind, of identifying the problem, suggesting specific ways to overcome the problem, and give helpful, encouraging tips for the future, I'd like you to assess the next 3 letters. And you can write what you think in the chat box. So any ideas about what you think the student has done well, and perhaps you could give some descriptive feedback. What is something that is strong, and what is something that's a next step for this student? Okay, so someone's pointing out that the word denominator wasn't used, so that would be a next step, is to bring more of the actual mathematical concepts into their feedback for Al. Someone mentioned they really like the visual representation, that was a great way of showing that, in fact, a half can be more than an eighth. I'm talking about being specific, making sure that you reference that those pizzas need to be the same size to begin with. The letter itself is encouraging, which is, you know, part of what was helpful. Okay. So, and again, as teachers, we can give feedback to the students. Some of our descriptive feedback should be in light of the criteria that we've set out. So we can address each one of the points of criteria and where the students, you know, really showed their understanding and some of the ways in which they, you know, they need to attend to some things or continue to grow. Okay, so we'll move on to the next one. Okay, and again, just reviewing the criteria. Identifies the problem or misunderstanding, suggests specific ways to overcome the problem, and gives helpful, encouraging tips for the future. Okay. So again, same thing, and if you could write in the chat box or along the side, it might be a little difficult because this one is full in any of the white spaces, but the chat box may be helpful. Yeah, I'm sorry, the writing is a little bit faint. I know I'm able to see it myself. So someone's asking the grade. This is grade 5. It's grade 5. Wait, grade 5, 6. Okay, someone said the visuals are now colored to show the portions being compared. So twins in grade 5, daughter would understand, but son would be confused. No discussion of denominator. Someone's saying it's only circles again. Okay, so again, thinking about how this exercise can really be thinking about in your own classroom how this exercise might be useful to your development of fractions. And after we do the third one, I'd love to hear from people about that, whether this is something you've done in your class, whether it's something you would use in your class. So one last time, we're going to look at one more example. So identifying the problem or misunderstanding, suggesting specific ways to overcome the problem, and giving helpful, encouraging tips for the future. Okay. Mm-hmm. Yeah. Yes. Mm-hmm. Right. So again, some comments, very to the point, uses math vocabulary, kind of confusing about the piranha and lizard, great sense of humor. Initially, I thought the student only wanted to look at the numerator, but I think he means both. Yes, so this student's giving the feedback to Al. So this is to Al. Hilarious but misleading. Should it be the numerator or the denominator? And two different visuals will likely confuse someone further. Okay, so again, some different thoughts about this one. And really fascinating, these opportunities we have to surface the thinking of our students. It gives us so much rich information as part of a formative assessment to see what is it that they're understanding. Are they able to identify key misconceptions? Are we seeing their own key misconceptions come in? Are they able to communicate the mathematical vocabulary that's required to demonstrate a deeper understanding? That's all information that we can surface through critical challenges and why they're really important. They do provide us with, I think, a broader, deeper picture of where our students are at. I also wanted to, people talk about open-ended questions, and I wanted to give some examples, and there's a great book, and I've got it in the references at the end. Some of you may have these books. There's two of them. There's one that's K to 6 and another one grade 5 to 8, and they're called Good Questions for Math Teaching, What to Ask and When to Ask It. And this is from their 5 to 8 book. So just take a look at some of these open-ended questions. And I'd love to know your response. Do you think these are good questions? Are these questions that you would feel comfortable using in your classroom? So someone mentioned multiple entry points. Okay, yeah, the middle one is definitely a challenging one. It's certainly more of a grade 8 question, and probably a bit of an advanced grade 8. pre-teaching around vocabulary, the use of prior knowledge. And again, these are great to have up on the board, right when students come into math or, to transition to math time, to get them thinking right away. And part of that, nurturing the community of thinkers and giving them a critical challenge, because all of these are a decode the puzzle, right? All of these questions are a decode. Yeah. What I love about the third question is where it gets extended in saying, think of a final clue so there's just one solution. Yeah, so again, a good point. How is this different from an action? You could absolutely use these questions for an action. Or they could be, you could use them as an action, or depending on your students and where you think they're at, you could give them a question that perhaps might be, maybe it's even a grade below from this book, but is relating to the concept, because we know that math is a spiral, and you could use that as an open-ended to get the thinking going. So again, that's where your professional judgment will come in, is whether you want this to be the action of a class or whether there are some of these open-ended questions that could be the initial minds-on for your students. Yeah, questions definitely promote collaboration and students asking more questions. Just want to make sure I get all the comments. Pre-teaching vocabulary. The third one would be a number that is a perfect square number. Then it would have only 3 factors because one of the factors would get multiplied by itself. Great. And again, just remember that this is, I'm not sure, I know some of you are at various grade levels. This is from the grade 5 to 8 book, and there is a K to 6. So again, depending on your grade level, to look for those and see. But it is, for people who want to do good open-ended questions, it really is a wonderful resource, and it is listed at the end of the presentation. Right. So the first is very hands-on. How could the other 2 use manipulatives to help them? It's a great question. Would you always band show? Again, I really think that these are the decisions that we're going to make depending on the context of our class. We are decision makers as teachers. I don't think that there is one program or one strategy that is going to meet all the needs of our students, or that we can pull out every single time and will have the same effect. So each time we're going to have to make those decisions about how we want to use the questions or how we want to employ the strategies and what we think is best and what's going to work with our students. Yeah, Marion Small has very similar open questions. It's true. I really love Marion Small. Gallery walks and stay and stray with students unless it's a critical curriculum point. Again, yeah, so many great ways. And Rich Math does have great resources too. Just want to make sure I get all of these. So again, I do think that sometimes we fall into this sense that we have to always do things, one way, or that there's one strategy. And I don't think so. I really do think that our judgment needs to come in there and make those decisions about what will work best. And also to, we do experiment in our classrooms. Our classrooms, we're learning all the time, and we're also engaged as teachers in our own inquiry. What happens when I employ this strategy? Which strategy for teaching number sense is most effective with these students? And we're engaged in our inquiry as teachers constantly. nothing that we're going to pull out is going to be the magic bullet. But again, what we can notice is when I'm engaging certain strategies, I do notice students are more engaged. Well, that's interesting. That's something I obviously want to continue. Or I'm noticing that the conceptual attainment was much deeper in this particular unit when we were using Bancho. Or, it could be that in a particular context, the gallery walk with my particular class is not effective for these reasons, right? And so we've got to continue to make those decisions and feel comfortable and confident based on what we're seeing to make the decisions, always with the aim that we have, which is to help our students achieve, to help them engage in thoughtful and rigorous academic learning, and continue to facilitate the social emotional piece, which is always a part of what we're doing as well. Okay, so stay and stray, someone explained, is when one pair stays and answers questions while the partner goes around and views the other responses and asks questions, and then they switch. I then have them run the consolidation by identifying what other strategies they saw that they would like to try next time. And thank you so much as well for bringing up the consolidation piece. And again, to emphasize, I think one of the most important things about the three-part lesson is that it is, as teachers, it's really, it is making explicit how important the consolidation is. And sometimes, we would think that a lesson has to end in a class period, but that's not true. A lesson can extend over 2 or 3 class periods, but it's very important that we do that consolidation piece. That's where we address the misunderstandings. That's where we intervene and bring all of that knowledge together, ensure that there is a deeper understanding and an accurate understanding of a concept. And I think that's where sometimes inquiry math has gotten a bit of a bad name, or seen as, discovery math, that students are just figuring out the answer, and as long as it's part of their journey that they're figuring out, we don't have to intervene in that. And that's absolutely not true. Critical inquiry is a rigorous inquiry. It is about accuracy. It is about effectiveness. And the consolidation piece is the critical piece where that happens. And again, that's why I think the three-part lesson is such an important format. Okay, so 2 relevant questions are how can we bump up the critical thinking in any math task? And I think we've been looking at that throughout this evening. And how can we support all students by explicitly providing intellectual tools? So going back and to the framework, I'm just going to pull it up here again. So looking again at the intellectual tools, thinking about the background knowledge. So some of you, when I pulled up those open questions, you're already thinking about that. Well, I need to teach the vocab. I need to make sure they understand the vocabulary first, or they couldn't really engage in the task. Or sometimes we get them thinking and we introduce the background knowledge, because a mismeme in education is that we always have to teach all of the content up front and then get students thinking. We can get students thinking immediately, but then also continue to introduce the concepts. And we talked about that in the first session, where I shared my experience of giving the students a very rich and challenging problem the very first day when I started a measurement unit. And the whole curriculum for measurement literally cascaded out of that problem. And what was amazing about it is that students were coming to class saying, are we going to learn about conversions today? Because they understood and they recognized that in order to solve the problem, they needed to understand conversions. Some of them said, we need to understand volume, like how do you figure out the volume? And so rich tasks can also drive the learning. And that's really important, that we recognize that background knowledge can also come in a meaningful way when students are engaged in a task, and suddenly the concept that they need to engage in that task is something that they want to learn because they want to solve the challenge. And that's a really beautiful part of engagement that comes by being challenged. Again, the criteria for judgment is something we've been looking at this evening, looking at effective solutions, helpful letters, all the different ways that we introduce criteria that can drive and deepen the thinking of our students, making sure they do have the vocabulary that they need, that that's not a stumbling block. If we ask them to estimate, you know, that's really important. When we ask them to solve, when we ask them to assess, do they understand what those words mean? The thinking strategies, so all the different ways that we're giving them, whether through manipulatives, as many of you mentioned, you use them a lot in your classrooms, to sharing our thinking, to number lines, all the different thinking strategies that can help our students. And again, those habits of mind, fostering the growth mindset and the perseverance is important. So going back to our questions, how can we bump up the critical thinking in any math task, and how can we support all students by explicitly providing the intellectual tools? We like to call this tweak and fortifying. And I think that's also one of the strengths of the critical thinking framework is this is not about you know, redesigning the whole program. It's really at times about these tweaks and fortifications we can do to the questions that we're asking or to the tasks we're already giving our students. One of the things I love about Dan Myers, who some of you may be familiar with, and he was the inspiration for a unit that I did that I spoke about in the measurement. He talks about using textbook questions, and one of the simplest things we can do to make those tasks critical challenges is to take out more of the information and use that, because often textbook questions have set up a question so that it's literally just a hop, skip, and a jump. The student applies the formula that you've been learning in class and they get the answer. And there isn't actually a lot of thinking in that. But how we can, for example, the question I did was a water tank problem where the original textbook question said the length of a water tank is 17 centimeters, the width is 6 centimeters, the rate of water flowing is 15 milliliters per second, how long will it take to fill in the tank? And you apply the solution. And the way we started is to say, how long will it take to fill the water tank? And we had a little video of the water tank. And then the students had to infer, well, I need to know the length, I need to know the width, we need to figure out rate. And it became a richer task. And sometimes that's a simple thing that we can do is not include all the information up front, but introduce it or help the students make the visualizations that, again, the textbook sometimes gives too much, so it's not as meaningful anymore. So again, these tweaks we talked about, the critical challenges, the critiquing the piece, judge the better or best, rework, decode, design to specifications. These are all effective ways that we can frame the tasks that we do that will bump up the thinking in any task. Those are some of the tweaks that we can use. Here's some examples as well. You know, the questions on the left are very good questions, but I want to ask you, what's the difference between the questions on the left to the questions in purple, the questions on the right? What do you think when you read those questions? Okay, so Kelly says the purple questions require judgment choices that need to be explained. They're set up to make the child empowered to answer. It seems as though the answer is within them already. Oh, that's a beautiful way of saying that. Thank you to whoever said that. That's really lovely. I'm definitely gonna I think share that with others. The purple requires analysis but doesn't limit. Yeah. So again, the questions on the left are good questions, but you can see that the critical thinking that's required with those questions on the right is much more present, right? It is asking them to make these judgments. Sometimes we use why, you know, and I know I've done this as a teacher, and why is so important. Like it's such a great question. The why question is such a big and important question. But I think sometimes we rely on that thinking that that will give us the critical thinking we want. I think it is a great activator for inquiry, but also being really intentional about setting up this problematic situation where a choice does have to be made really does bump up the critical thinking. So it's not about not having the questions on the left in our class, absolutely not. But it is about being more intentional at times about the kinds of questions we're asking and how we are inviting students to make that reasoned judgment, because that can lead to the deeper concept attainment. Another great frame that we talked a lot about in our first session is, does your answer make sense? And to unpack what it means to make sense. And this is something I know that we are constantly wanting our students to do, because they'll hand us something and we'll think, oh, you know, like they've done all this work, but that final answer doesn't correspond. It really doesn't make sense. And how can we make that a reflex for our students and unpack with them, what does it mean? What is the criteria for a solution that makes sense? Right? And we can use it in a number of ways. We can frame a number of different tasks in the math classroom with that frame. Does this answer make sense? Does this calculation make sense? Does this estimate make sense? Does this count make sense? Does this solution make sense? And again, possible criteria. And I'm sorry, I'm rushing a little because I know we're at the end. I would have had you all thinking about that, but I do want to make sure we end on time because I respect that you're all here and I know you've got busy lives. But some criteria could be that it answers the question, it fits with the information in the problem, it fits with what I already know about mathematics in the world. And again, putting this criteria up and asking students to go through a process when they're solving a problem to assess their own answer and to judge their own answer in light of the criteria, to have that extra step. And this is when we talk about the independent use of the intellectual tools, that it isn't a matter of them coming to you, is my answer right, is my answer right? And we have, you know, as teachers, it's very hard because we have what researchers call the didactic contract. The idea is a student struggles and we want to step in and help them. You know, that's what we want to do, but sometimes we need to step back and think about, how do we intervene in this situation and with what? And what are the ways that we can help students independently apply the intellectual tools? We need to teach them the tools, and how can we help them apply them? So making this part of the classroom, you know, does your answer make sense? Like you could do a whole like display board about this, right? It could be very exciting to get at that notion of sense making in the math classroom, right? Versus right and wrong, which again I think increases the anxiety in our students. Moving into, does my answer make sense? That is empowering for them. So again, just a reminder of creating a thinking classroom. How are we nurturing thoughtful communities? How are we framing critical challenges? Teaching the intellectual tools and assessing thinking and performance. And ways that we can fortify. We do have a number of great tools for thought on our website, and these are more in-depth tutorials. They've got rubrics included with them that you can revise to meet the needs that you have in your classroom. But we have great tools for thought on how to visualize a math problem, how to analyze a math problem and check the solution. We have that were included as part of this. We have some great classroom discussion papers on ways to frame a math problem using critical thinking, on how to employ critical thinking in the elementary mathematics classroom. And we also have a piece on deepening mathematical reasoning. And those are not part of the tools, but they're part of tips for teachers. So we have on our website, and if your board is a partner with us, using your workplace email, you can access all of our resources for free. If your board is not a partner with us, I think our annual membership is about $40 a year, but it does give you access to fantastic resources. And again, we have other tools for thought, including writing reflectively in math and science, monitoring problem-solving progress, organizing data, inferencing, and we're continuing to work on our math resources. Yes, so there's a partner link where you can find out if your board is a current partner. And these are some of the recommended resources. Catherine Bruce talking about student interaction in the math classroom. Sherry Parrish, that is a more expensive resource